Hello everyone, I am Shreya Ghosh and Data Science and Business Analytics intern at the Sparks Foundation. Today I will be explaining about my first task, which is prediction using supervised email. The objective of the task is to predict the number of a student based on his or her number of study hours. The model that we have used is linear regression and have used Python with supervised machine learning to accomplish the task. The task will be processed through the following steps, and the steps are as follows. In step 1 is importing the dataset from Excel. Step 2 is preparing the dataset. Step 3 is training the dataset. Step 4 is testing the model or making predictions. Step 5 is visualization of the model. And the last and sixth step is evaluating the model or diagnostics. So let's start. Step 1 is importing the dataset. Let us first import some libraries that will come handy throughout the task. So first I'm importing pandas as PD, which is basically the alias of pandas. Then from sklearn.model selection, I'm importing trend test split. From sklearn.linear model, I'm importing linear regression. From sklearn.metrics, I'm importing R square score. And also I'm importing matplotlib as PLT. This library will basically help us in the visualization of the data. Now we will be importing the data set which is stored in CSV format in my computer system. The function pd.readcsv is used to import the data set. This is the location of the file in my system. So after importing the data set, we will store the data set in a variable called stdy. We got the data set now. This is as follows. There are two columns in the data set, hours and scores. So we can see that if a student studies for 2.5 hours, his or her score is 21. If he or she studies for 5.1 hours, his score is 47. 3.2 hours, score 27, and it goes so on. Now let us observe the properties of this data set. stdy.shape, it gives us the number of rows and columns of the dataset. We can see that there are 25 rows and 2 columns. stdy.columns, this function gives us the name of the columns of the dataset. Hours and scores are the name of the columns of our dataset. Now before preparing our dataset, let us first check if our dataset have any missing values or not. stdy.isna.sum, this function is used to get the number of missing or null values. We can see that the hours column has 0 null or missing value, and also the scores column has 0 or 0 null or missing values. Hence we can move on to our next step, that is preparation of the data. Step 2, preparing the dataset. In this step, we will first divide the dataset into independent, which is the study hours or the x variable, and dependent, which is the marks of the student or the y variable. The function stdy.iloc, this function gives us the value of the hours column. The colon represents that we are considering all the rows, and colon -1, it represents that we are considering all the columns except the column with index 1, that is the score column. Then we will be storing these values in the variable called x. And now we got the values of the study hours column as follows: 2.5, 5.1. These are the values of the study column. In a similar fashion, we will be storing the data points of the score column in y variable. So now that we have defined our x and y variable, we will split the dataset into testing and training data. We will use the train test split function. Here we are taking test size equals to 0.2. This basically means that we are randomly selecting 20% of our dataset for testing and the remainder 80% for training. Now we are using the function xtrain.shape, xtest.shape, ytrain.shape and ytest.shape. It tells us that there are 20 data points in each columns of the training dataset and there are 5 data points in each column of the testing dataset. Now moving on to our third step, which is training the dataset. In this step, we will be training our xtrain and ytrain dataset. So I'm calling the function linear regression and then storing the function in a variable called model. Now we are training our xtrain and ytrain data points, which is nothing but fitting a regression line throughout the scatter plot of xtrain and ytrain data points. Let's store the model in a variable called training. And then we are printing that the training of the model is complete. We can find out the intercept and the coefficient of this fitted line by using the function training.coef and training.intercept. These are as follows. The next step is testing the model and predicting the model. Pred equals to model.predict x test. It predicts the values of the y variable, that is the scores based on our x test data point. We are storing these values in a variable called pred. So these are our predicted y values that we have predicted based on our x test data point. Now let us have a look at our actual y test data point. These were our actual data points and these are the predicted data points of the score of the student. We can notice that though the number though the values actually may not be exactly equal, but they are somewhat close to each other. So when the actual score was 62, the model has predicted the score to be 59.20. When the actual value of the student score was 88, the model has predicted it to be 90. When it was 30, the model has predicted it to be 28, and it goes on like that. Let us now predict the scores of the students based on their study time. So we got this equation y equals to 2.89354722 plus 9.5448810 into x. This is nothing but the equation of the fitted line that we got previously during our during our training of x and y train dataset. That is here. So if our x, which is the study hours of the student, is 8, we are getting the predicted score of the student to be 79. In a similar way, we can predict the score of the student based on his study hours. We can take x equals to any number as the study hours and then we can predict the score of that student. The fifth step is visualization of the model. So we have stored this equation of the fitted line into a variable called line and then plotted the training data and the fitted line using matplotlib library. So this is the graph. The x-axis here represents the study hours of the student. The y-axis represents the exam score of the student. And the red dots indicates the scatter plot of the x train and y train dataset, and this blue line represents the fitted line, that is this line. In a similar fashion, we have plotted the test data points and fitted line too. So here is the red lines here, red dots here represents the scatter plot of the x test and y test data set, and the blue line is the fitted line. Now coming to our last and sixth step, which is evaluating the model or diagnostics. In this step, we will basically evaluate the accuracy of the model. we will be using R square score and errors to measure the accuracy of the model. So I'm using the function R square score y test pred. R square score is the R square score basically tells us the goodness of fit of the model. It tells us how close the actual data and the predicted data are to each other. The closer the value of R square score is to 1, the better our model is, or the better the accuracy of the model is. So here we can see that our R square score is 0.93, which is very close to 1. Hence we can say that our model is quite accurate. Errors is nothing but 1 minus R square score. It tells us how much error is there in the model, and the lower the value of this errors is, the better the fit of the model is. So we are getting 0.06, which is pretty low. So we can infer that our model is quite accurate. So with this, the task comes to an end. Thank you.